Welcome on and all to the Math Magic Show. This one's find the area under this curve. In other words, we're going to find the value of the integral between 0 and 10 of f of x. Now this here curve represents the function f. We don't know what it is. It doesn't matter. It's described using a piecewise function, quite a few different pieces in fact. This graph, just so you know, is made with Desmos. It's a great graphing website. Let's go through this process. So when you have a complex shape like this, to answer the question of finding the area under the graph, you simply break it into recognizable geometric shapes. Let's go to the first one. So the first shape that I recognize, for example, is the fact that this here could be interpreted as a simple rectangle. And the area of a rectangle is the base times the height. So in this case, if you look carefully there, the height will be 3 units, and then the base is 1 unit. So the area is 3 times 1, which is 3. 3 times 1, which is 3. We might add that as our first piece here. So this is first equal to 3. Then we move on to the next piece. So next I might recognize that over here, this represents pretty much a triangle. The height of the triangle is 1. The base of the triangle is also 1. So you apply the basic triangle formula. So the area here will be 1/2 base, which is 1, times height, which is also 1. So you multiply that and you get 1/2. So I'm going to put this down as plus 1/2. I'm building up everything piece by piece by piece. Okay, then you recognize the fact that this right here, that represents basically a square. So let's take a look. That's going to give us that this is a base of 2 and a height of 2. So I'm going to multiply them together. So I'm going to have 2 times 2, which is 4. So here to my value, I'm going to add the value 4. I then continue. The way you decide to break up the shapes is really up to you. So just try to look for recognizable geometric shapes, but there could be some flexibility in how you choose to do this. So what I'm showing you perhaps is a way, but not perhaps the only way. Okay, just keep that in mind. A way. Next, I again recognize, for example, that this here and that is basically another triangle. So that area again would be equal to 1/2. It's the same as this triangle up there, see? So that area is also 1/2. So I'm gonna add 1/2 to the sum that I'm forming up top. And then, again, down below, I have some flexibility. I could, if I wanted to, recognize, for example, this whole strip here as representing just a rectangle. I can do that. So when I calculate this one, I look at the base. So the base is 8 minus 3, which is 5. So 5 units in the base. And I'm going to multiply by the height, which as you can see is just 1 unit. So it's 5 times 1, which is 5. And I add that to the sum that I'm forming up top. Okay, so I continue. I now recognize the fact, for example, that this here is a triangle. See, this forms a triangle. So the base of this triangle is 2 units this way. The height is 2 units that way. So you multiply and then you form 1/2 of that quantity. So I'm going to have, for this part right here, 1/2 of 2 times 2. Well, you cancel the 2's off and that gives a balance of 2. Okay, so I'm going to add that to my value up top. That's 2. Let's continue. Now I might recognize as an example the fact that this here represents a square. So that area would be the 2 in the height and the 2 in the base down below, because this here is 6, right? And if this is 8 along the x-axis, 8 minus 6 is 2. So I get 2 by 2. So 2 by 2 is 4. So the area for that piece is 4. It contributes 4. Then I recognize the fact that up here I basically have a semicircle. So if this is the center of the semicircle, then here this is the radius. So the radius is 1 unit. So I could draw it this way too, for example, or this way. The area here would be found as follows of that semicircle. 1/2 pi and then the radius squared. So 1 squared is 1. 1 times 1/2 is 1/2. So I end up with 1/2 pi. So I'm going to add that here, 1/2 pi as that piece. And lastly, as an example, I recognize that over here I have again a triangle. So down below me, so to speak, so I can find that area as follows. I recognize that the height of this triangle is what I'm tracing. So that's equal to 3 units. The base of this triangle is from 8 to 10 down below. So that's 2 units. So it's 2 and 3 up this way. It's 3 this way. So 3 times 2 will give me 6. But then, because it's a triangle and not a rectangle, you get to multiply as always by 1/2. So the 2's will cancel and you end up with 3. So this area here is 3. So I'm going to attach that to this sum. So I'm going to put plus 3 in this position. The rest of this is just bringing it into perhaps a more neat form. And we can do that pretty easily here. It's not too complicated. Let's actually go through that process. Why not? So take your 3 And let's see, the 4, that's 7, and this 3, that's 10, and this 4 is 14, and this 2 is 16, and this 5 is 21. So let's see, let me not miscount, that's 21 already. And then 21, and now you take care of the 1/2. So this is 21 and a half, 21 and a half, and another half is 22. And then the only piece that remains is 1/2 of the pi, but I'm going to keep that separate. So it's 22 plus 1/2 of the pi. And you don't want to combine those because pi is already a nice clean form. But this is pretty much the value then of what we were looking for right here. Thank you so much for watching. Please leave a like and subscribe. I'll see you in another video.